In these trying times that keep lingering on for now, we're going to have to say half a decade of trying times or more. Today's video is about passive shortwave receivers, crystal radio sets is the common term, and a useful feature that you might want to build. WWV subset H and B out of various locations in the United States, and many others like it, internationally as well. We're going to be talking about one of the oldest radio stations that's in continuous use, that's been doing a continuous time signal transmitting and announcing the time every 60 seconds. The NIST, National Institutes for Standards, etc. Physical Measurement Laboratory, Gaithersburg, Maryland, originated Time and Frequency Division for the U.S.A. This is part of many, many systems that are designed to act as a part of the infrastructure that is literally invisible, weighs nothing, and really doesn't cost much. Across the shortwave band at multiples of 5 megahertz, that's half that frequency, double, triple, etc. We have 2.5 megahertz, and that's at 2.5 kilowatts. That's all it takes. At 5, 10, and 15 megahertz, it's 10 kilowatts. And then at 20 megahertz, it goes back down to 2.5 kilowatts. These are used to transmit a voice code, tones that are picked up by a touch tone-like receiver, among other things, and also purely digital transmissions. Since 1919, WWV out of Washington, D.C. transmitted. 1931, WWV was at Gaithersburg, Maryland, and or moved around a bit. 1948, WWVH was at the Pacific Missile Range, Barking Sands, Kekaha, Kauai, Hawaii, and has a female voice, Jane Barbe, or Barbe, a voice actor. 1963, WWVB, data only, out of Fort Collins, Colorado, started up. It's a pseudo-digital transmission. I'm not going to go into details because it contains analog and digital data, so, you know. And then Fort Collins, Colorado became the home of all of them other than the one in Hawaii in 1966. Fort Collins, Colorado, or near there. Now, we have the frequencies to work with here. And we're going to talk about crystal radio sets if you want to in another video. Here's how to build it. Using a high impedance earphone. It can be a crystal earphone for $6, or you can use your normal earbuds with a $2 transformer if you look hard enough. Audiophiles have absolutely ruined high impedance for headphones. I don't think you're going to find 2 to 4K ohm, average 3K ohm coil earphones for any reasonable price. So the way you do that, if you somehow need that, even though they keep saying audiophile mumbo jumbo bullshit, is if you want to plug into one of those sets, you use an impedance matching circuit, or you use an analog or digital amp to convert it. It's a variation on line level impedance abused for putting out headphone levels, or maybe even speakers. It's based on using the old crystal shortwave transceiver set headphone standard, but making better quality earphones. And yeah, if you're an audiophile, you're going to start screaming below. I don't care. What these are important about is we can use a passive signal from a radio signal itself to power the headphones. It's an extremely low power. Now, what you do if you have low energy level, low power, let's say it's 1 microwatt, is if you figure out that it's at a high impedance, the air is a high impedance, the communication's high impedance, you could get it, let's say, at 4K ohms, and it will be a sufficiently high voltage that you can detect it through an amplifier. It won't be very high voltage at all, but you can then run it through a matched set of headphones that are matched to 2 or 4K or whatever it is. 600 ohms are also available, and that will provide you the ability to transfer as much energy as possible, because if they're matched, even though between them the apparent voltage, if you measure it open-ended, will drop by half, you'll get half instead of it dropping to like 1/100th. And it'll put through as much energy as possible if they're matched. That's what impedance matching is about. That's why the front of a trumpet has that weird shape to it. That impedance matches from the interior of the trumpet or tuba or whatever to the air outside by creating this interesting effect. A pedantic person will come along, especially an audiophile that are fake pedantics, and start quoting physics rules that don't exist. Mock them freely in the comment section. I fucking hate audiophiles. They ruin transformers. 1K ohm to 8 ohm transformers are $2. The ones that would go 4K, which were for long line transmissions for telephone lines, it's a telephone transformer, used to be available really cheaply from Radio Shack, this big. I would use them for line level coming out of those RCA jacks off the back of a record player and run them to my headphones by running through a transformer. That's the advantage with high impedance. You can get away with taking a signal that would normally have to be amplified and just feed it to a set of headphones and listen to it. Or pick up a really weak signal that happens to do high impedance if you do the right kind of wiring. There's a way of wiring capacitors, inductors, and diodes to do a high impedance and tune it to a frequency. Here we go. After that long-ass rant, you need a germanium diode. A 1N32 diode is suggested by many sites. You're going to need a bunch of coils, or look up how to make a old Quaker Oats container-based coil for tapping by frequency and also tapping by impedance matching certain frequencies in the shortwave range so you could pick up radio signals all over the world. These are foxhole radios taken to the next level. And then after that, it has to have a variable capacitor for fine tuning. The coils can also be used purely for tuning. This is a passive system that picks up the push and pull effect of the radio signals, and depending how weak and how strong they get, this can be run through a diode, which only gets the push parts. If it's a hard push, a punch, your headphone will move in further. If it's a weak one, it moves in a little bit. And it's based on it going through a capacitor that makes it to where it'll wobble back and forth freely without being pushed constantly forward. This creates audio. There's a bunch of complexity to it. I'm oversimplifying it, but this is a passive circuit that listens to the entire radio spectrum and potentially takes all of the radio signals in the area and uses it in effect to drive it. There's a way of picking up the entire bandwidth, all of it, fully rectified off the coil, off of a separate antenna and coil, or off of a resonant one where you tune it to a really powerful station you don't want to listen to, and use it to dump power across a capacitor to power a little amplifier to run all of this. You can build an entirely passive system, or just put a solar cell on a standard radio. Anyway, the signals, again, are at 2.5 megahertz, 5 megahertz, 10, 15, and 20 megahertz. And these are announcing the time, occasionally useful information, but mostly just time. And some of them do digital or quasi-digital data. They transmit only data, sound and data mixed, or just sound, depending. There's a bunch of variable answers. Someone's going to correct me in the comment section. I know ham operators are always right, but you're almost as bad as the audiophiles because it doesn't matter. I'm talking about all of these frequencies, and that's the next step. Depending on where you are, they're all transmitting exactly the same thing. So build an individual crystal tuner for each and feed them out to where that they feed by after the diode. You have to do a separate stack for it. All of them feed in at the same time without interfering, and then have that power everything. One of them will be more powerful than the other, and they just give you time and date stamp. If they're transmitting exactly the same information, you can combine the information, or more accurately, the power. But yeah, a simple diode, which used to be constructed by oxidizing a razor blade, a capacitor that could be made by just foil or even layers of wire wrapped to be one side or another of a capacitor, and coil headphones that were available at the time for radio sets, because the higher in the impedance, the less amplification you had to have, or the more sensitivity it had because there wasn't any amplification at one time. The only amplification was sending a signal by triggering either audio, which was hard and took a lot of work, or just literally closing a connection and having it run a spark gap. for pulses. Anyway, Jane Barbe is the female voice of WWV out of Hawaii, and the rest of the places it's a male voice. And there are equivalents to this in many countries, or just picking up general transmissions. And yeah. Now, when you look up, if you look this up, God help you if you look up any of this, you will find lots of websites who've been infested by audiophiles that sell these transformers for hundreds of dollars when they were literally $1 or $2. And yes, I know there's a major difference between them, and I know that you dangled that little pendulum crystal over it to make sure it was perfect, blah, blah, blah. I don't give a shit. We're just trying to pick up a signal so we know what time it is. Or maybe if it's that time. So if you're going to build a crystal radio set, again, you can use any signal source, including a solar cell, a battery, or a radio signal or noise source, highly rectified to act as an amplifier power source, and or gang all the frequencies together, and or just listen to it through, literally, it's a $6 crystal earphone off of Amazon and a $2 audio transformer from them. And the rest of it is don't buy the high-end microphone, phones. The next thing is, if you can find an old, really high impedance microphone, these are dynamic mics, they amount to being, if you use them the other way around, a 600 ohm high impedance earphone that actual impedance may even be higher. Just saying. And they're $1 a pop. You can buy the elements. They're just called dynamic microphone elements. Using them as headphones work fine. But again, you can buy a crystal radio set and just alter the capacitors and inductors. The rest of it, lots of long wire, and learn how to make antennas. You'll end up making something that looks like a spider web or some weird ritualistic thingy. That's it for today. Bye.